Today we want to talk about graphing a rational function. We want to use the asymptote and any key points of the rational function as aid to sketch the graph. Let's look at the concrete example. F of x equals x minus 1 divided by x plus 4. Step 1, we're going to determine the y-intercept, if there's any, by setting x equals 0. In this case, f of x is defined at x equals 0 with the function value being -1 first. So that's going to be our y-intercept. Next, we're going to determine the x-intercept by setting this function equals 0. This is going to imply the numerator equals 0 at the same time the denominator does not equal 0. So if we solve for this will give us the x-intercept being x equals to 1. And that's the only x-intercept we have. Next, we're going to determine the asymptotes. Let's start with the vertical asymptotes by setting the denominator equals 0. So that's going to give us the equation of the vertical asymptotes being x equals -4. When x equals -4, the numerator doesn't equal 0, so we don't have to worry about any holes. The next step, we're going to determine the horizontal asymptote. Because the numerator and denominator are of the same degree, the horizontal asymptote is going to be y equals to the ratio of the leading coefficient of the numerator and denominator. In this case, is y equals 1. In the next step, we'll determine whether the graph rational function is going to intersect with the horizontal asymptote by setting the rational function equals to the constant function, which represent the horizontal asymptote. So we set f of x equals 1. This gives us the rational equation to solve. So we can solve it using the procedures we learned earlier. First, we start with restricted values. The denominator cannot equal 0, so x cannot be -4. Next, we determine the least common denominator. In this case, is x plus 4. We multiply by x plus 4 on both sides. That's going to give us this linear equation. And we subtract x on both sides. That's going to give us -1 equals 4, which is a contradiction. This says this rational equation has no solution. In other words, there's no intersection point with the horizontal asymptote. So now we have all the key facts, and we want to set up a coordinate system so that we can capture all this key information. So here is my x-intercept, here's my y-intercept. This is the horizontal asymptote, here's the vertical asymptote. So because of the graph is going to pass through these 2 points without intersecting with the horizontal asymptote and the vertical asymptote. So that's going to give me this branch of the curve look like this. And again, there are not going to be any curves in this portion and any curve in this portion because it's not going to intersect with y-axis here, and it's not going to intersect with the x-axis in this region. So there's no curves in these 2 regions. But on the other hand, because of the rational function is defined for all real numbers except for x minus 4, so we do expect there will be a portion of the curve appear to the left -4. It's not going to be here, so it has to be up here. So this is what the remaining curve, remaining portion for the graph rational function is going to look like. So next, let's look at another example. G of x equals to 4x squared plus 7x minus 2 divided by x squared plus 4. We're going to follow the same procedures to sketch the graph for this rational function. Let's start with the y-intercept. By setting x equals 0, this gives us g of 0 equals -1/2. Next, we're going to determine the x-intercept by setting the numerator equals 0 at the meantime requiring the denominator to be not 0. In this case, the denominator is not going to be 0 for any real number, so we don't have to be worried about that. So let's solve this quadratic equation to determine any 0 of the rational function. So we can factorize this quadratic form as the product of the two linear factors. So that's going to give us two zeros for this rational function, one being -2 and one being 1/4. And these two numbers will represent the x-coordinate of the x-intercepts. So next, we're going to determine the vertical asymptote, if there's any, by setting the denominator equals 0. As we mentioned earlier, for any real numbers, the denominator is not going to equal 0, so there's no solution for this. In this case, this rational function has no vertical asymptote. Next, we determine the horizontal asymptote because the numerator and denominator are of the same degree. This implies the horizontal asymptote is going to be y equals the ratio of the leading coefficient of numerator and denominator. In this case, is y equals 4. Okay, the last step, we're going to determine whether the rational function is going to intersect with the horizontal asymptote by setting the rational function to equal the constant function. So that's going to give us this rational equation. Again, we start with restricted values. That's going to make the denominator equal 0. In this case, it's never going to happen. So we can start with multiplying the least common denominator, which is x squared plus 4, on both sides of the equation. That gives us this equivalent form. And we try to move the quadratic term to the left-hand side and combine them together. That's going to cancel out all quadratic terms. This is going to give us a linear equation to solve. Eventually, we have the solution being 18/7. Since this rational equation does have a solution, this implies the rational function does intersect with this horizontal asymptote. So now we have all the key points and asymptotes, and we want to set up a properly scaled coordinate system so that we can capture all of these key features. Okay. So these 2 points are my x-intercept. This is my y-intercept. This is the horizontal asymptote. We don't have any vertical asymptote. And this is intersection point with the horizontal asymptote. So in other words, my curve has to pass through these points. So let me connect these 3 points first. And eventually, the rational function has to approach this horizontal line. So at some point, it has to curve back. This point is going to be turning point. We don't have to worry about exact location. So going to the left, eventually the curve has to pass through this point. In other words, in between, there will be another turning point. Okay, and then going up, all the way to the left, approaching this horizontal line again without intersecting it. So this is going to be the graph of this rational function.